second method. The second method. Please see the PPT. See the PPT.
Yes, sir.
This one can also be included in this group. So there are two divide methods. They are all right.
Yes, sir.
They are both right. Then, if we have grouped the expressions, then we can use Karnaugh to determine the minimum SOP expression. The rules are: group the cells that have ones. Each group of cells containing ones creates one product term composed of all variables that occur in only one form. Either uncomplemented or complemented with the group. Variables that occur both uncompleted or complemented within the group are eliminated. So if the variables that occur both uncomplemented or complemented within the group are eliminated. For this Karnaugh, the four ones are in one group. What is the corresponding product term? What is the corresponding product term? From this rules, we know that each group of cells containing ones creates one product term. So this group creates one product term, right? Can create one product term, and composed of the product term composed of all variables that occur in only one form. One form is that only equals 1 or only equals to 0. For this variable a, it occurs in 0 and in 1. For c, it occurs in 0 and 1. So the two variables are eliminated. Only b equals to 1. So the product term of this group is b. Understand?
No.
Please read this paragraph. Group the cells that have one. Each group of cells containing one creates one product term. So this group can create one product term, right?
Yes.
And the product term is composed of all variables that occur in only one form. One form means its value is only 1 or only 0. The value of the variable cannot be 1 and 2, 1 and 0 in the same group. Only one form with the group. One form. What is the one form mean? Either uncomplemented or complemented. Either 0, either 1 or 0. But cannot be both 1 and 0. Please read this sentence. Variables that occur both uncomplemented or complemented with the group are eliminated. So for variable A, 0 and 1, 0 is complemented, 1 is uncomplemented. So this variable must be eliminated. And C also 0 and 1 are occur. So C can also be eliminated. The product term must be B. Right? A because this is A bar, this is A. This is A bar, this is A. So A bar plus A equals 1. This C bar, C. So C bar plus D also equals to 1. So the product term only contains B. This is the rule A. Rule B. Determine the minimum product term for each group. For all 3 variable maps, for one cell group, yield all 3 variable product term. Or 2 cell group, yield all 2 variable product term. 4 cell group, yield all 1 variable term. 8 cell group, yield all variable of 1 for the expression. For example, this Karnaugh, 3 variable Karnaugh. There are 4 cell groups. So this group yield all 1 variable term B. 1 variable P. If the groups include 4 ones like this, what is the product term?
4 cell group yield 1 variable term.
If there are 4 ones in the 4 cells, what is the product term?
4 cell group.
4 cell group yield or 1 variable term.
Yes.
What is the product term?
A1.
A bar. Right. Very good. Samimo. Very good. Because in the group there are B bar and B, C bar and C. So B and C are eliminated. Only A bar is retained. When all the minimum product terms are derived from the Karnaugh, they are summed to form the minimum SOP expression. For example, for this Karnaugh, there are two groups. Each group contains 4 ones. So each group creates one product term, and the product term contains one variable. The green circle group represents B, and the blue group A bar. So the minimum SOP expression is A bar plus B. Let us do the exercise example 10. There are five product terms. So there are 5 ones in the Karnaugh, and we know that there are 3 groups on the Karnaugh. For the red group, what is the product term? A bar, B bar, yes. A bar, B bar. A, B bar. A, B bar. C bar. So the product term is A bar. A. So A must be eliminated. A, B must be B bar must contain. And C bar must contain. So the product term of the red group is B bar, C bar. Right? Yes. And the green group is A, B bar. A, B bar. C bar, C. So C must be eliminated. So the product term is A, B bar. For the blue group, A equals 0 and 1. So A must be eliminated. B equals 1. And C equals 1. So the product term is BC. So the simplest SOP expression is BC plus B bar, C bar plus A bar. The first method. The second method. If we divide the ones into these 3 groups, then this product term is B bar, C bar. This product term is BC, right? But this green product term is AC, right? AC, not AB bar. So the second simplest SOP form is BC plus B bar, C bar plus AC. These 2 expressions are equivalent, and they are both They are both the simplest SOP form. There are 3 AND gates and 3 AND gates and 1 OR gate. 1 OR gate. 2 inverters. 2 inverters. Also, this expression also has 3 AND gates
2 inverters.
and 1 OR gate. 1 OR gate. 2 inverters. So, if we know the Karnaugh, how to map the Karnaugh? If we know the truth table, how to create the Karnaugh from the truth table? The method is the ones in the output column of the truth table are mapped directly onto our Karnaugh into the cells corresponding to the values of the associated input variable combination. For example, like this truth table. All combinations are listed on the truth table. How to get the Karnaugh? First, we must find out that
Output 1.
and the output, which output is equal to 1. 1, 1, 1, 1. So there are 4 product terms. 4 product terms equal to 1 in the Karnaugh. So there are 4 ones in the Karnaugh. 4 ones in the Karnaugh. The first is 0, 0, 0. So the first one in the cells are 0, 0, 0. The second is 1, 0, 0. 1, 0, 0. 1, 0, 0. So we must find out the cell, the corresponding cell 1, 0, 1, 0, 0. So this cell must be 1. And the third 1, 1, 0, 1, 1, 0. This one 1, 1, 0, 1, 1, 0. So the corresponding cell equals to 1. And the fourth 1, 1, 1. Fourth 1, 1, 1. See? So there are 4 ones on the Karnaugh. The other cells vary are 0. That is the method to the method of convert our truth table to our Karnaugh. It is very easy.
Yes.
The important readout, the Boolean expression, the truth table, and the Karnaugh are simply different ways to represent our logical function. 3 different ways. Besides this way, logical circuit and the description of the logic function are the other 2 different ways to represent our logical function. So we have learned 4 different ways to represent our logic function. Logical circuit, Boolean expression, truth table, and Karnaugh. The description of the logic functions are just just a text expression. And then the description of the logical function is just a text expression. So we don't regard this expression as an expression form. So we in fact we have laid 4 kinds of expression ways to represent our logical function. There is another very important concept. Don't care conditions. Don't care conditions. What is don't care mean? Sometimes all situations arises in which some input variable combinations are not allowed. These unallowed states will never occur, so they can be treated as don't care terms. So the don't care terms can be 1 or 0. Can be 1 or 0. The don't care terms can be used to advantage on the Karnaugh because they will never occur. Either a 1 or 0 may be assigned to the output for these don't care terms. For example, when the BCD code for 7, 8, or 9 is present on the inputs, the output is 1. The output is 1. Output is 1. How to represent this logical function? We know that BCD code just contains 10 different values from 0 to 9, right? From 10 to 15 are not contained in BCD code. So the six product terms are don't care terms. Because the six values are don't allowed to happen. Right? So the output is X. X represents 1 or 2. So we don't care the value of the output of six product terms. So we first convert the truth table to Karnaugh A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0. And we know that there are 3 ones in the truth table. So there are 3 ones in the Karnaugh. On the Karnaugh, the first one is 0, 1, 1, 1. So 0, 1, 1, 1. 0, 1, 1, 1. This product. This 1, 0, 0, 0. 1, 0, 0, 0. So this. And the third one, 1, 0, 0, 1. 1, 0, 0, 1. So the 3 ones are on the 3 cells. And the 6 product terms are output X. So we must must write down the 6x axis on the column map. 1 0 1 0 1 0 1 x 1 0 1 1 1 0
1 1
1 1 1 1 0 0 1 1 0 0 1 1 0 1 1 1 0 1 that's 1 1 1 1 0 1 1 plus 1 0 that is 1 1 1 1 1 1 1 1 1 so the column of the truth table is like this. Then we must group the ones. Group the ones. Because x can be regarded as 1 or 0, so we can divide the 8 cells into one group. Because the 8 cells product term is the simplest form. So we must contain as more of the possible ones, as more of the possible cells into one group. And for this one, we need to group these two cells into one group. We cannot group 4 cells into one group for the one. So the most suitable group is this one and this one. So if we use don't chaos condition, then the output is for this group, the product term is A, B, B bar. So B must be eliminated. C bar, C. So C must be eliminated. D, D bar, D. So D also must be eliminated. So the product term of this group is A. And for this product term, the A bar, so A must be eliminated. B, C equals 1, D equals 1. So the product term is BCD. So the simplest form is A plus BCD. A plus D. We use don't chaos condition. If we don't use don't chaos condition, then we know that the two ones can be grouped into one group. And this one represents one group. So for these two ones, the product term is A B bar, C bar, right? And D bar, D, so D must be eliminated. So the product term is A B bar, C bar, A B bar, A B bar, C bar. And for this product term, A bar, B, C, D, A bar, B, C, D. So the last SOP expression is A, B bar, C bar plus A bar, B, C, D. If we don't use the don't chaos condition. So from this example, we know that Don't care condition can help us to simplify our Karnaugh. That is the tense of for chapter 4. In chapter 4, we have learned this key term. The first key term is variable. Variable is a symbol used to represent a logical quantity that can have a value of 1 or 0. Usually designated by an italic letter A, B, C, D, E, F. Complement. Complement is the inverse or opposite of a number. In Boolean algebra, the inverse function expressed with a bar over a variable. The complement of 1 is 0, and vice versa. The third key term, sum term. The Boolean sum of 2 or more literals equivalent to all operations. Equivalent to an OR operation. Product term. The Boolean expression product of 2 or more literals equivalent to an AND operation. Equivalent to AND operation. Sum of products, SOP, is a form of Boolean expressions that is basically the origin of ended term. The origin of ended term. Product of sum is a form of Boolean expression that is basically the ending of all the terms. We didn't learn this form. Karnaugh is an arrangement of cells representing the combinations of literals in Boolean expressions and used for a systematic simplification of the expression. Karnaugh is used to simplify a Boolean expression. That is the function of Karnaugh. Minimization. Minimization is the process that results in a SOP or POS Boolean expression that contains the fewest possible literals per term. Don't care is a combination of input literals that cannot occur and can be used as 1 or 0 on Karnaugh for simplification. Okay. Chapter 4 finished. And then chapter 5. Chapter 5. Combinational logic analysis. Please turn to page 115. 50. Combinational logic analysis. First, combinational logic circuits, and we have learned that the sum of products form basic combinational circuits can be directly implemented with AND-OR combination if the necessary complement terms are available. if for this expression, it is on SOP form, AB plus CT. From this expression, we know that there are two AND gates, right? And one OR gate. And because each product term can be represented used on AND gate, right? A and B use AND gate. C and D use AND gate. Then AB plus CT
OR gate.
use OR gate. Okay. This is the logical diagram. And the formula is on ANSI standard distinctive shape symbol. We can also use another symbol like this. This symbol is ANSI standard rectangular outline symbol. We usually use this symbol because it is easy to understand. This is a storage tank monitor. If all the storage tanks are empty, then the output will be 0. It will be 1 or 0 to indicate that the 3 storage tanks are empty. This is a low level indicator. How to write the expression, the Boolean expression of this diagram? AND gate. So this is BC plus AC plus BC AC AB
Yes.
So
AB plus BC plus AC.
So x equals to
AB plus
AC plus AB, right? Plus AB. Plus AB plus BC. How to get the truth table? So we must write the truth table. First input A, B, C, and then output X. Then the values must from 0 to 7. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Then the output is AC. AC it equals A B bar C plus A B C, right?
Yes.
And AB equals A B C plus A B C bar. A B C bar. ABC. So we don't need to write it again. And BC. A bar BC plus A bar BC plus ABC. ABC is Yeah. So we don't need to write it again. So there are 4 ones. 1, 0, 1. 1, 0, 1. So equals 1. 1, 1, 1.
Plus 1.
1, 1, 1. Equals 1.
A, B, C.
And 1, 1, 0. 1, 1, 0. So it equals 1.
0, 1, 1.
0, 1, 1.
The fourth
0, 1, 1. 0, 1, 1. So from this truth table, we know that if there are more than 2 tanks are empty, then the output is 0, because 0, 0, 0 represent all the 3 storage tanks are empty, and 0, 0, 1 represent A and B are both empty, and 0, 1, 0 represent A and C are empty, and 1, 0, 0 represent B and C are empty. So this logic gate can indicate if the storage tank are empty. If the storage tank is empty, that is one application of combinational logic circuit. AND-OR-Invert logic. If we use AND-OR-Invert logic to represent an SLP expression, then the SLP form is inverted. The circuit is called an AND-OR-Invert circuit. The AOI configuration lends itself to product of the sums implementation. For example, if we add an inverter to the output, then A, B, C, D bar, A, B, C, D bar, inverter. So the last output is A, B plus C, D bar. According to the De Morgan's law, do you remember?
Yeah.
We know that it equals AB bar and CD bar, right? It equals AB bar and CD bar. AB bar and CD bar. AB bar, according to De Morgan's law, we know that AB bar equals A bar plus B bar, and CD bar equals C bar plus D bar. So this form is the product of sum, because this is a sum form. So they are ended. So the form is a product of sum. Exclusive or logic. The truth table for an exclusive OR gate is shown like this. This is the note that the output is high whenever A and B are unequal. That is mean they are different. If A and B are different, then the output is 1. Other, the output is 0. So we can use this logical diagram to represent this expression. This is B bar, right?
Yes.
B bar. So the output is AB bar.
And this is all gates.
And second, this is A bar.
And
B. So the output is A bar B.
so AB bar plus A bar B.
Yeah. We use this symbol to represent on exclusive or logical. This symbol. This is the ANSI distinctive shape symbol. And we can also use this symbol. This is our ANSI rectangular outline symbol. We can find the symbol on page 151.
This is also in chapter 2.
So the Boolean expression of the exclusive or logical is A bar B plus A B bar. Okay, class is over.